Hi everyone, my name is Jitendra. In this video, this is the part 6 of Core Java series, and in this video, we will be learning some of the topics like instance of casting, upcasting, downcasting, final keyword, when to use, final keyword with methods, class, variables, and some of the object class methods like equals method, hashCode method, toString method, kind of these things. Okay, so we'll just understand those topics, and these are not theory part. Mostly we'll have to write the code, so we'll understand the code for everything. Like first thing is instance of. As you can understand, as you can see, the instance of meaning instance of means a part of, object of. So with the help of this instance of operator, what we do, we check whether a reference is a part of some class. Instance of checks whether it is instance of or part, not the part of. It is, like for example, I have dog class, right? And I have a parent animal, and in parent animal I have created a dog class. In dog class I'm checking, I have created one instance. Let me show you by the code. Let's just write here, instance of, it is object of same type. So we do it for the validation purposes. Whenever we write the code, before validating or before doing something with that reference, we check whether we have that particular instance of class or not. So I'll write one class, or what should I do? Let's write class only. I'll write animal, and I'll give miscellaneous here, miscellaneous. Okay, now we have animal. I'll write one more class. I'll write class dog here. So I'll give animal to this uh, as a parent, and dog to this, and I'll extend animal here. Okay, what does it say? Public type of dog must be one. Okay, that's me. CLA. Let me create a separate class for this as well. Dog. Oh, okay. Rename. This animal. Rename. What am I doing? I've done rename for animal. No, why am animal rename to rename file. Okay, now make it dog. Rename in file. Rename in workspace. What's happening here? Let's delete both of them. Hanging. Right click. Delete. Here is delete. Continue. Now create CLA class animal. Oh, animal. Now create one more class, dog. CLA dog. Now I'll extend, because dog is an animal, so animal is the parent animal. Now what I'll see here, what I'll do here, I'll write one main method, and inside main method I'll create an object of dog, new dog, and I'll do the upcasting here. I'll have the parent variable, and this is upcasting where we give the reference of the parent class. This is upcasting. Let me write here upcasting. Okay, upcasting means bigger parent. SYSO. Now I'm checking. A is instance of dog. Okay, next thing. A is instance of animal. Next, A is instance of cat. Cat we have not write. Let's write cat class. So I've written cat also. Instance of cat or not? What is happening? Because it is not instance of cat. And last, null is instance of dog. Okay. So this is not, A is not instance of cat because cat is not related to animal or dog. Although it is an animal, but we have not extended it. Okay, that's why it will not be the instance. Now let's print for every other. Let's run it. So instance of A is instance of dog. Yes, because dog is an animal. A is instance of animal. Yes, because animal, dog is an animal. Again, the same relationship we have. Null, instance of dog. Again, false. Null will never be the instance. Null is not an instance. Null is never instance of. Okay, so this is the part where we have understood instance of. Now let's go for casting. So where here we have done upcasting, we can also do the downcasting, but that would give us the error. So let's write some example at the bottom. Casting, we are saying, let's say we have in dog class, where is the dog class? This is the dog class, and I'm writing some parameter here, private string name of the dog. Okay, and next thing I'm writing private int age and private string breed. Okay, now let's create a constructor also, so that we can create a constructor. Now let's go new dog. We have to create the constructor with sorry default constructor also. Okay, now let's do this. New dog. I'll give name Tony, age 3, and the breed is Labrador. And I'll do the casting here. I'll have this animal. I'll give name an here. Reference we have given here. So when we have done like this is called upcasting, where we have a dog animal, we can do. This is always safe. Why this is safe? Because we are going from smaller to the bigger one, because an animal can have multiple animals like dog, cat, lion, tiger, but a tiger is an animal. That condition, if we go opposite of this, let's say I'm doing this. I created new animal and I'm giving here the reference for cat. Cat C goes to new animal. So here it will give us error. It is giving error because every animal should. It is not necessary that every animal will be a cat, but we can do so. Like if I do this, no, it cannot be cast because what's happening here? Because the animal can be a dog, tiger, horse, anything it can be, but it is not necessarily would be the cat. So this is not safe. This is wrong. This is not safe. This is downcasting, but this is safe to upcast. This is safe to upcast because upcasting means the broader term like animals, fishes, and humans. In human we can have male, female, child. So that's the logic here. Now let's do one thing. Let's do downcasting with dog. I'm creating. I'm writing dog d equal to a n. So here an is an instance. It is referring to dog object. If I do this, it will accept because it is a dog, right? So this is accepted because it is a dog. But if it is not a dog, then it will not accept. So similarly, this is safe because an is an object of dog. But if the case is like this animal and what we are doing with cat, but this animal is not actually a cat, so then that's why it is throwing error. But if I do like this, let's say I am creating one more variable, I'm writing here cat. Okay, so let's see cat, and if I give here this, cannot cast from animal to cat. Or is this quick? Okay, this is not extending animal, so we have to extend cat. Where is cat? Extends animal. So see, this is also accepting this because this, now we are downcasting. This is animal, we can do this is, and this comes under animal now because we have extended. Okay, now let's go to the next part. If I go, what is the use of this? Its use is this: whenever we are dealing with upcasting and downcasting, we always go for checking if an is instance of dog. An is an instance of dog. We check every time. We check if it is an instance of dog, then we'll do some operation in the dog object. Otherwise, we do not. An is instance of, is not it is not is instance of dog. Then we do something. If it is not, we do something. Depends on the process. Okay, so that's the instance of part. Okay, now let's move on to the next part where we have the final keyword. So what is final keyword? Casting we have done. Casting can be of two types: upcasting, downcasting. Casting upcasting, and what is upcasting? I'll give upcasting first. Giving parent reference to the child object. This is upcasting, which we have done here. You can see there, this is animal is parent and this is child. We have given the animal reference, which is hen, to dog. This is upcasting. But what is downcasting? Downcasting is opposite of this, giving child reference to the parent object, which we have checked and it was giving some error. I will save it later. Okay, so this is what this is casting. Now let's go to final keyword. Final is a keyword I'll tell you a few more things with final. Like final is not exactly comes alone, it comes with two other keywords also. So final is the keyword which is used with method, class, variables, and variables. Okay, so final itself says final. Whenever anything is final, it cannot be modified, it cannot be changed, it cannot be extended based on whatever we have. So if a method is final, it cannot be overridden. If a class is final, it cannot be modified. If a variable is, it cannot be extended also. It cannot be given to the another class. And if a variable is final, it cannot be modified, it cannot be muted, it cannot be changed. Okay, so that's the case. So let's go for example. So we have cat. I'll write here only. So let's write final int num equal to 10. So if num is already given 10, if I try to give num equals to 19 again, it will not allow us because it is already final. So there is, let's do this in main. Remove. Final variable cannot be changed, cannot be reassigned. Similarly, if a method is final, it cannot be overridden. So let's say public static final get name void get name. Okay, so if I try to override this in any of the method, like animal, I have animal, so let's do one thing. I'll have animal, yeah, okay, I'll extend, this is wrong, extend, I'll change, no worries, let's create one more class, A. Now in A I am extending cat, extends cat. Now I'll try to override this method. So what is it saying? It says the method getName A must override or implement the super type. Remove override annotation. If I remove this, cannot override the final method from the cat because final method cannot be overridden. What's next? Final class. If the class is final, let's say cat, I put it final. So after that, it is giving error that a cat uh, cannot be final subclass. Type A cannot be subclass of the final class because it cannot extend the final class. So that is that final keyword. Now let's go to the last topic. Before moving on to the last topic, let me give you other two topics also in this. Final keyword comes with his two friends. One is finally and other one is finalize. You'll see this finally with exception handling. Okay, I'll explain you later. Finalize is used. It is used for garbage collection. Garbage collection means whenever we have created an object and it is no longer in use, it will be garbage collected and removed from the memory. Okay, so this is that. Now let's move on to the our topic. Let's do this. So final from here. We do not want to see this red in our system. Let's do comment out this. Close all. Project. I'll create CLA class. I'll create one class named product. In this product, what I'm doing, I'm having some fields: private string SKU and private string name, private double price. Okay, now I will create constructor using field. Now the method object method will see, so the first method will see equals method. So we have to override this method for the object equality. Override this to make sure the equality of objects. We check the content of object. Now we can do this also. Generate toString, generate hashcode and equals. I'm writing hashcode and equals. So this hashcode is it has given the equals also. In equals we have object. This is equal to object, and we will, if it is equal we will return true, if it is null we will return false. We check if get class not equals to object or get class both are not same, then it will return false. And then product we'll see, we'll have the obj is what, the object reference. We see the product reference and the object is a supermost class, these both are same. Then we'll go for returning, we'll check the equality. If the name and other dot name, this name is equal, then we'll check for this one. We'll check and verify for everything. If all are these equals, then it will return true. Okay, next thing, hashcode is what, it gives us numeric value, and whenever hash is same, then the equals value, so there is a contract between equals and hashcode, so I'll give that one also. So let's see, when the values are equal, then we have to make sure we override the hash code also. Why? Because two equal values will always have the same hash code. That means if the values are equal, then the hash code has to be equal. That's the issue. But otherwise, if hash code is same for two values, if hash code, but the first condition we have completed. We are saying, but hash code can be same for two different values. You understood? So what I'm saying here, if the values are equal, let's say I have given Jitendra, and these are two equal values in two different variables, then the hash code must be same. But if I have two different values, first in Jitendra, then Kashyap, it can have the same hash code, right? So hash code can be same two different values, but if the values are same, then hash code has to be equal. That's the concept here. So that is why this comes in groups in pair. Whenever we are overriding, we are checking equality. If we are overriding equals method, then we has to override the hash code method also. It's a contract. It's the understood part. Okay. Now let's go to the next method. Next method is we have toString method. So what toString method does? toString method gives us the vector readability. Vector readability. Okay. Other method we have how vector readability. If we do not have this, it will print the references, the reference address. Otherwise, if we write toString method, it will give us the value. You see this product, this is a string, then sq, this sq is this exact value will be given like this. Sq is this, name is this, price is this. It will be shown like this. Okay, in an array. So in like this string. Now we have one more clone method. So let's see if we have, let's write it here. Protected object clone return super dot clone, and we have to throw some exception here. As throws clone not supported. So whenever we are creating a clone of any object, we have to override this also, and we have to, whatever object we are cloning, we have to implement cloneable. Override clone for deep copy. It must implement the clonable interface. Okay, so that's all about the object methods. Okay, I think we have covered it all. Okay, thank you guys.